When we talk about hard drives, we're normally talking about a hard disk drive. Now, from the outside, there's not much that we can see about a hard disk drive. It really just looks like a big metal block. But when we take a look at the inside, we can see a bit more. Now, you never want to actually take apart your hard drive. Once it's exposed to the air, once it gets dust particles in there, it destroys the drive's ability to actually read and write data. It's very, very precise instruments and very precise measurements that allow that drive to be able to work. And once you open it and once it gets dust in there, there's nothing that you can really do. When they actually open drives for drive information recovery, they do it in rooms that are completely sealed of any dust or particles so that there won't be anything that gets inside those drives for contamination. But for demonstration purposes, we have opened a drive. Now, this particular drive, as we can see, is a hard disk drive. And when we say hard disks, what we're actually talking about are these series of these disks right here. These disks are referred to as platters, and we have stacks of them on the drive. On this particular drive, there's 2 of them stacked together. Now, these platters are actually coated with a magnetic coating, which allows us to write on that drive either a 1 or a 0, a positive or a negative, which we then later read. That's why we say we don't want magnets to come in close contact with drives, because it can destroy that data by changing the magnetic information on those drives. It's the same way with, say, tape drives, which also write in magnetic data. We do not want magnets to come in contact with them or even come close to them. Now, what actually writes the information onto our drive here is called our spindle. This small spindle, when it's actually on the drive, doesn't touch the drive. That would scratch it. It actually rides just above it, just very slightly above it, and is able to write that information, the 1s or 0s on the drives. It writes them in sectors on the drives, which are not something that we can see on the drive, but when the drive is formatted, it actually breaks it up into logical sectors that the information is written onto. This spindle is actually several spindles which go in between the drives and can write on the different sides and write on the different drives. And there's actually 3 different writing heads that can go onto the drive and write the information onto there. The back part here is called the actuator, and this is what moves the spindle precisely to where it needs to be in order to write the information on the drive. Now, when we encounter drive issues, you may hear things called head crashes, or you may hear grinding noises with your drive. That indicates that you're about to have a drive crash. Your hard drive's going to crash. Now, when we talk about head crashes, that's when this spindle head actually crashes down onto our drive, and that's going to destroy our ability to write, and that's going to destroy our drive. Grinding noises can indicate that the spindle is actually starting to scratch our drive, or the actuator may be failing. Now, all of these are things that we want to back up our drive and get it replaced as soon as possible, because once we have a situation such as a head crash where the drive mechanically can no longer work, can no longer mechanically read or write data, it becomes a very expensive process to send off that drive and open it up and have them at a laboratory manually take these disks apart, manually take these platters apart and read the data off of them. Drives can run at several different speeds. A couple of the speeds that we may see referenced on, say, our exams are going to be 5400 RPM. And the RPM stands for rotations per minute, how many rotations per minute our drive disk can run through, the small platters that we saw can turn at. We have 7200 RPM. There's also 10,000 RPM and 15,000 RPM. And again, RPM stands for rotations per minute. The general standard rotations per minute for just a standard daily use drive that, say, we have in our computer, 7200 is a good drive speed to have. It increases our ability to read and write information off the drive quicker. But if we need, say, a larger drive that's used for a server instance where we're reading and writing data very rapidly off of that drive, the faster rotations, the higher rotations per minute we have on the drive, the faster that drive can spin and read and write data off of the drive.